Okay, for question 3, when a high-energy alpha particle collides with a beryllium-9 nucleus, a nucleus of carbon with proton number 6 may be produced. What are the products of this reaction? Okay, so first, it's telling us that we have an alpha particle. So recall that when we have an alpha particle, the symbol for that is alpha, or you could also use helium. 4 number of nucleons and 2, okay, is the number of protons. It is colliding with beryllium-9 nucleus. So if it's colliding, it just makes sense that it will combine, it will react with beryllium, and the following information is provided. Okay, the number of protons and the nucleon number of the element. And it's telling us that there is a possibility that a carbon element will be produced, such that the nucleus here, a nucleus of carbon may be produced. So you could just kind of write it this way. Okay, I'll put carbon there just to kind of set up what's happening. And before even considering anything else, if I want to balance this equation, if you will, notice that 9 plus 4 will yield 13, and 4 plus 2 will yield 6. Okay, so this is kind of our sketch, if you will, of the situation. Now it's telling us that carbon must have 6 protons. In this particular equation, that is true. Okay, notice that we have 6 here. However, the problem we have is none of our choices have carbon 13. Okay, it's either carbon 12 or carbon 14. So how will we do this? What we need to do is we need to find an equivalent for this one over here from among the choices. Now, before we do that, please recall the following, that in terms of our protons, neutrons, and electrons, okay, we recall, I'll put it here on the side, that if I have a proton, okay, I can write that as the following, P11, okay? If I have a neutron, that can be expressed as like this, okay, N10. And additionally, if I have an electron, recall that that can be written as 0, -1. Okay, so we will use this to kind of figure out what will go with whichever one we choose, so that this is still equivalent to what we have over here. Okay, so if I choose carbon 12, such that the number of protons must still be 6, because that's stated in the problem. Okay, let's test out this one. If that's the case, I will have 12 here, 6 at the bottom. If I'm going to combine that with a proton, I should be adding the following, P11. But the question is, does this equal carbon 13, 6? No, because I may be able to get 13 here, but I will have 7 protons, but I should have 6 according to the problem. So immediately I cross out X. Okay, let's test out this one. If I have carbon 12, okay, still same number of protons, okay, plus if I choose a neutron, will I end up with this one here? I should, right? That should give me carbon, if I add this, 13, 6. Okay, so immediately I know that B should be the answer. And you could test it out with carbon 14 and the proton. Okay, if we do that, let's just try it out. Okay, so 14 here, and then with the condition that you have 6 protons. If I combine that with a proton, okay, I will not get this. This will not be equivalent to what I have there, because this will be 15, 7. Obviously not the same. And then same here. Okay, if I have carbon 14 with 6 protons, I combine that with a neutron, okay, I will still have 6 protons. However, my nucleon number will not be 13 anymore. So the only valid option here would be letter B.